more integration by parts. So for this one, I have integral of x root of x plus 1 dx. I'm going to get u as x, so it just becomes easier when I integrate, and when I derivate, and dv over dx root of x plus 1. So I derivate this one, so du by dx is 1, and I integrate this one. So v is going to be square root of x plus 1 to the power of 1/2 dx, sorry, which is x to the x plus 1 to 1 more, so 3/2 divided by 3/2, the new exponent. Yeah, and then I go back to my integral and substitute using the formula. So I have to do uv, so uv, I'm going to write the 2 at the top, so 2/3 of u vx plus 1 to the power of 3/2 minus integral of v. I'm going to write the 2/3 outside, 2/3 outside, and I have x plus 1 to the power of 3/2 dx, and this is the first part, 2/3 doesn't change, x plus 1 3/2, and now when I integrate this one, I increase the degree by 1 and divide by the new exponent. So I have 4/9, no, 4/9, no, the new exponent, no, wait, I'm not going to skip steps. So 2/3, and then I have x plus 1 to the power of 5/2 divided by 5/2 plus c, and I can just simplify a tiny bit. So I have 2x, 2/3 of x plus 1 3/2 minus 2/3 to 4/15. So I divide by the fraction, so 4/15 x plus 1 5/2 plus c. Yeah, that's it. Then e is integral of x divided by e to the power of 3x dx. And I know it doesn't look like integral by parts because most of the questions are factors instead of a fraction like here, but think that this is x times e to the power of minus 3x, so it's exactly the same. I'm going to call ux, and I'm going to call dv by dx my e to the power of 3x. I derivate this one, du by dx is 1, and I integrate the other one. So v is going to be integral of e to the power of 3x, minus 3x, because this is in the numerator, yeah? And dx, and this is e to the power of minus 3x divided by minus 3. Remember how we integrate exponentials. So this is uv, so I have x and this whole thing, so I'm going to write minus x divided by 3 e to the power of minus 3x minus integral of v, and I'm going to take the minus 3 outside, so minus 1/3 integral of v e to the power of minus 3x and 1 dx. Yeah, I'm just using the formula. The formula is in the formula booklet. And I integrate that second part, and I have minus x over 3 e to the power of minus 3x minus 1/3 e to the power of minus 3x divided by minus 3 plus c. And I can organize a bit the coefficients. So this e to the power of minus 3x, and then plus 1/9 of e to the power of minus 3x plus c. Yeah. And the last one is x sec square. So I'm going to do here f is going to be integral of x sec square, x sec square x dx. So I can call u to my x, I can call dv dx is sec squared. I derivate this one, so the u by dx is 1. I integrate this one, so v is the integral of sec square x dx. Did you know that is tan? Or is in the formula booklet if you don't remember. So when I substitute back here, I have u v, so x tan x, minus integral of v, which is tan x, du dx, which is 1 dx. And we have to think a bit how we integrate that tan x, because it's not one of the immediate ones. So we can write tan as sine divided by cos. This is how I integrate tan, sine divided by cos. And that way we have that the numerator, if we include this minus, is the derivative of the denominator. So this is a function, this is the derivative, which means the integral is going to be the natural log of this denominator. Yeah. So this is going to be x tan plus, because this minus goes together with the minus sign, with the sign to be the derivative, so plus ln cos x plus c. Yeah, squeeze this a bit. And that's it.